Hey everyone, and welcome back. So, you've worked your way through the first chapter of university physics, which you know is all about building that super solid foundation. In this explainer, we're going to pull all those core ideas together. Think of it as a high-speed review, just to make sure those key concepts are really and truly locked in. Ready? Let's dive in. You remember this incredible image, right? The Whirlpool Galaxy? It's just the perfect way to kick things off, because it captures the whole point of Chapter 1, that the entire universe, from something this huge down to the tiniest subatomic particle, is all governed by the same, surprisingly few, simple laws of physics, and our job is to figure them out. So here's our game plan. We're going to tackle this in 4 quick parts. First, we'll revisit the why, the scope and scale of physics. Then, we'll get into the how, by reviewing its essential language. After that, we'll focus on the one key equation from this chapter. And finally, we'll tie it all together with a lightning round summary of each section.
Okay, first things first. Before we get into all the nuts and bolts, let's just zoom out for a second and remember the big picture. What are we even trying to do here? What's the fundamental goal of physics?
This quote from the textbook just nails it. The whole mission of physics isn't just to describe how complex everything is. It's to find the simple patterns underneath it all. It's about discovering those few, elegant rules that govern literally everything. That's our why.
Of course, to even talk about those patterns, we need a really precise language. So this next section is just a quick refresher on the most important vocabulary from Chapter 1. Think of these as our foundational tools.
All right, here's our first batch of essential terms. Now, we're not going to read them all out loud, but you can see we've got things like accuracy, base quantity, and dimension. These are the absolute building blocks for everything that comes next. I'd really recommend just pausing right here to scan these definitions and jog your memory.
And here's the next set. This one covers fundamental units like the kilogram and the meter, but also really crucial concepts like estimation and order of magnitude. Again, feel free to hit that pause button and make sure these all look familiar.
And here we are, the final list of terms. This one's got some heavy hitters, like precision, significant figures, and uncertainty, words we are going to be using constantly. So this is your last chance to pause and review the vocabulary before we see how it all gets put to use.
So, now that we've got the language down, let's look at the chapter's key mathematical tool. This is the equation that helps us put all these concepts into practice.
The one key equation for this whole chapter is for percent uncertainty. And this is so important because it's how we measure how precise our measurements are. You know, in physics, a number by itself is pretty much meaningless unless you know how confident you can be in that number. This simple formula gives us a standard way to express that confidence.
All right, let's get to our final section. We're going to do a real lightning round here. We're going to connect all those vocabulary words in that key equation to the big ideas from each part of the chapter, one by one.
Okay, section 1.1. This is where we got our mission. Find simple laws that describe all natural phenomena. We learned that physics operates on this huge range of scales, length, mass, and time, and that we use models, theories, and laws as our tools to make sense of it all.
Then, section 1.2 was all about measurement. The big idea here is that our systems of units are built from just a few base units, like the meter, the kilogram, and the second. And we talked about the 2 main systems, SI units, which is the metric system scientists use, and English units.
Next up, section 1.3 gave us the critical skill of unit conversion. The main takeaway? You use conversion factors to cancel out the old units and bring in the new ones. And you always have to remember that units follow the rules of algebra, especially for things like area and volume.
Then we had dimensional analysis in 1.4. This is such a powerful idea that any valid physics equation has to be dimensionally consistent. It's an amazing tool for checking your work and just making sure your formulas actually mean something in the real world.
Next, in 1.5, we got into the practical art of estimation, sometimes called Fermi calculations. This is all about using good physical reasoning to get a quick, rough, back-of-the-envelope answer that tells you if you're even in the right ballpark.
Section 1.6 brought us right back to the details of measurement. We defined that crucial difference between accuracy and precision, and we learned that significant figures are how we communicate the precision of our tools in our final answers.
And finally, section 1.7 gave us this brilliant framework for solving problems. It's a simple 3-step process. 1, create a strategy. 2, do the math and find the solution. And 3, and this is a big one, always check for significance. Does your answer actually make sense? And there you have it, our whirlwind review of Chapter 1.
We've covered the huge scope of physics, its essential language, and the basic skills you need to start solving problems. So as you keep going, the real question to ask yourself is this: which one of these foundational skills are you going to focus on mastering first?